inverse hyperbolic functions. Okay, let's try to understand what these are. Before that, let's look at our circular inverse functions. So we know if sine x equal to y, then x is equal to sine inverse of y, and we have commonly used this very often. For example, when we say sine theta equal to 0, we can say theta is equal to sine inverse of 0. The way we read it is, for what angle of theta will the sine be 0? Sine of that angle will be 0. So in this case, theta will be equal to 0. Similarly, cos theta equal to 0. So theta can be written as cos inverse of 0, which means basically pi by 2. So this is what inverse is all about. Now, instead of just x or y, let's look at complex numbers. So similarly, if we have sine x plus iy is equal to u plus iv, then in that case we can say x plus iy is equal to sine inverse of u plus iv, right? And sine x plus iy is equal to, if you make it periodic, sine n pi plus minus 1 to the power of n x plus I y. Basically the general form. Okay. Now, which means we can write this as sine inverse of u plus iv is equal to n pi plus minus 1 to the power of n x plus I y, which basically means that it is a many valued function. There will be many values for this function. Now the general value of sine inverse of u plus iv is going to be n pi plus minus 1 to the power of n x plus I y, which can be written as n pi plus minus 1 to the power of n x plus I y can be written as sine inverse of u plus iv. The principal value would be the real part lying between minus pi by 2 to pi by 2, basically to make sure that the vertical line test is passed. Now, so what we saw was as far as the sign is concerned of a complex number and its inverse. Now let's look at the cos of a complex number. So x plus iy is equal to u plus iv, which means this can be written as cos inverse of u plus iv is equal to x plus iy, and cos of x plus iy is equal to cos of the periodic form n pi plus x plus iy, or in other words, cos inverse of u plus iv is equal to n pi plus cos inverse of u plus iv, right? Looks confusing. You have to focus on it a little bit and try to understand. Okay. Now, if y is equal to hyperbolic sine of x, then we say x is equal to hyperbolic sine inverse of y. And similarly, we will have an inverse for all the other hyperbolic functions. So hyperbolic cos inverse of y, hyperbolic tan inverse of y, hyperbolic cosec of inverse of y, hyperbolic sec inverse of y, and hyperbolic cot inverse of y. Now, in case of circular functions, if we have said y is equal to sine x, we will have x is equal to sine inverse of y. Y is equal to cos x means x is equal to cos inverse of y. Similarly, y is equal to tan x, x is equal to tan inverse of y. Y is equal to cot of x, x is equal to cot inverse of y. Y is equal to cosec x, so x is equal to cosec inverse of y. And finally, y is equal to sec x, x is equal to sec inverse of y. I'm just repeating it so that you really get to get the feel of it. Okay. Similarly, y is equal to hyperbolic sine of x, which means x is equal to hyperbolic sine inverse of y. Y is equal to hyperbolic cos of x, x is equal to hyperbolic cos inverse of y. Y is equal to hyperbolic tan of x, x is equal to hyperbolic tan inverse of y. Y is equal to cosec x hyperbolic x. So x is equal to hyperbolic cosec inverse of y. Y is equal to sec hyperbolic x. So x is equal to hyperbolic sec inverse of y. And finally, y is equal to hyperbolic cot x. X is equal to hyperbolic cot inverse of y. Okay. So understand this, because as we go forward, we will look at some more, some additional concepts. For example, expressing these in terms of logarithms. That's it for now. Bye.